Assalamualaikum everyone, welcome back to this channel. This is Miani Vaid and you are on the channel of Medicare. So as you know that we have started the lectures of pharmaceutical chemistry 3 and we have covered a lot of topics from this syllabus. And in today's lecture we are going to start this chapter which is about trimeric analysis. And we are going to discuss all the methods to do the titration, and we discuss some types of titration as written in our syllabus requirements. First type is acid base titration, second is oxidation reduction titration, mean a redox titration. Third is agiometric titration, which is also called as precipitation titration, complexometric titration, and the last type is non-aqueous titration. So we will discuss in this lecture all the types of titration as I can. And now we are going to start the titration methods of analysis and how we do that. We will discuss it. Okay, before we gonna to start all the types of titration, I'm gonna to explain you what are the trimeric methods of analysis, or what is trimeric analysis and why we do that. So actually, trimeric analysis, these are nothing else. Methods. They are some methods, analytical methods to determine something. Okay, so they are methods, they are gonna to determine. And what thing they are gonna to determine? They are used to determine the quantity of a reagent. They are used to determine the quantity of of a unknown concentration of a reagent. Okay, okay. So these are the methods in which we are going to determine the quantity of any reagent whose concentration is unknown. We don't know what concentration of this reagent is, but we use some methods to determine it. And how we determine it? We use something. We react this reagent by another reagent whose concentration is known to us. So we are gonna to react it with some analyte, okay, and we know its concentration. So its concentration is known to us. ठीक है, हमें इनकी concentration पता है. So अब आप इस तरह से now you can define trimeric analysis or trimeric methods. Said these are some special kind of analytical techniques or analytical methods that are used to determine the quantity of an unknown concentration of a reagent to react it with an analyte or another reagent whose concentration is known. And so this is the trimeric method, and we use some types of trimeric analysis. So there are 1, 2, 3, 4, and 5 types of trimeric analysis. So there are five types of trimeric analysis. The first type is acid base titration, second type is redox titration, third type is precipitation titration, fourth is complexometric titration, and the last type is the non-aqueous titration. Now we will discuss the whole detail of every type. So first I'm going to start the first type of titration, which is acid base titration. So this is the first type of this method, the first method of titration. Okay, so what is it? So in this titration we are going to determine the concentration of acid or base using our neutralization reaction. Okay, what is going to happening in this titration? We use two things here, one is acid, one is base, and same thing reagent. Okay, now we use the word reagent in it. Now our reagent can be acid or the base, and it comes. Okay, so In this titration, we have one reagent. We use two total reagent in it. Okay, first reagent whose concentration is known. We know the concentration of it. And second is unknown. We don't know, and we have to find it out. What concentration it has, we have to find it out. Okay, so now our first reagent whose concentration we know, it can be a acid or it can be a base. Similarly, our this reagent can be acid, can be a base. Let's suppose I am giving you the example that this is a acid. I'm giving you any acid like HCl is a acid, and I know its concentration. I know its concentration, and like I know its concentration is 2%. We know that. And the second reagent that I am giving to you is a base, but we don't know its concentration. We don't know anything about it. So we can find it out by using acid base titration. And the acid base titration is nothing else, it's just a reaction between these two. It's a neutralization reaction. Neutralization reaction, in neutralization reaction, the acid and base react with each other and they form salt and the water. Similarly, when the neutralization reaction occurs, we can find out the unknown concentration of the base. Similarly, your non reagent can be a base. It can be a base. I can assume it a base like NaOH. This is a base. And similarly, I can put acid as an unknown reagent. Now they both will react and give us the neutralization reaction. It can be happen. So that's why we can find out the concentration of a acid or a base by neutralization reaction. So this was the definition of acid base titration. So in the neutralization reaction, water is used as a solvent. And why water is used? Because it is easily available, it is have very low cost, and it is non-toxic. It will not react with your base and acid. It will not damage them or disturb their reaction. It will facilitate this reaction. So that's why the water is used in it. Okay, so after discussing it, now we discuss sorry for it, we will discuss the principle of acid base titration. So what is the principle of it? So the basic principle of acid base titration is our neutralization reaction. So this is our neutralization reaction. This is the basic principle here. Why? Because any acid or a base, they both will react, giving a neutralization reaction here, and produce a salt and water. So this is the neutralization total general reaction. What how the salt and water form? Because your acid is gonna to donate the hydrogen ion, and this hydrogen ion will be accepted by the base. So base is the okay, if so base will accept this hydrogen ion, and it also donates OH negative ion. Okay, so this hydrogen and this OH will combine to form water here. Okay, if I am going to give you a simplest example by which you can understand this concept easily, this is very simple. You study about the neutralization reaction in the as a base, you know about it all. So this is a acid HCl plus I am taking any base NaOH. So what the reaction happen? The HCl donates a hydrogen. Okay, this hydrogen, and this base donates OH negative ion. They both will combine to form water. Now what the thing remains? Cl and Na. NaCl will combine to form a salt. This is a simple neutralization reaction. None difficult in it. So during the neutralization reaction, the actual reaction occurs between one hydrogen positive ion from the acid and the one OH ion from the base. They both react to form water, and salt is actually a byproduct. So major reaction is between these two ions. Okay. So this was the basic principle of your titration. So in the titration you can use the reagents. As I have told you, we use two reagents here. This reagent can be a strong acid or can be a strong base. Okay, so you have known that always a reagent can be a base or acid, but you have to choose any strong acid or any strong base. You can choose one strong acid and one weak base. Okay, so I'm going to tell you how much types of reagent you can choose. Okay, so I'm gonna to raise something so that I can get the space here. So now the reagents that you can use here. Okay, so in the acid base titration you can choose many reagents. On the base of reagents, the acid base titration have several types. So four types it has. So I'm gonna to discuss all these types here. Okay, so the first type is the combination of a strong acid plus strong base. Both are strong. Can you give me the example of any strong acid? Yeah, HCl. Any other? Yeah, H2SO4, very strong acid. Any strong base that you know? Yes, NaOH. And any other example? Yes, KOH. They both will react to give you the acid base titration reaction, and their byproduct pH will be equal to 7, neutral pH. Okay, so the next titration that you can do is between the strong acid plus weak base. Okay, strong acid will be the same HCl or H2SO4, anything that you want. But could you remember any weak base? Yes, NH3, ammonia is very weak base and its pH will be less than 7. Less than 7, not greater than 7. Its pH will be less than 7 always. Okay, the third type of it will be the reaction between weak acid. Now I am taking weak acid, not weak base, and the strong base, opposite. Okay, strong base will be NaOH or KOH, and weak acid, can you remember any example of a weak acid? Yes, acetic acid, NaCH3COOH, very weak acid it is. And the result pH will be greater than 7. Greater than 7. Okay. And the fourth reaction can also be occur between a weak acid and a weak base. Weak acid will be acetic acid, for example, and the weak base is NH3. uh, but it cannot be formed. It's very difficult reaction, and mostly this kind of titration occur within a non-aqueous titration. It cannot be occur within the presence of the water or aqueous solvent. Okay, so this will happen when we have non-aqueous titration process. This reaction is belongs to that, but the first three types, they are in the example of acid base titration. And they have curves also. They have titration curves. Every type has a titration curve. Now I'm gonna to draw the titration curve here, on the this side of them. So the first curve is between a strong acid and a strong base. So how you will find out their curve is like that. Okay, so here we have the pH of it. Like we have 0 pH, here we have 7 pH, here we have 14 pH. Okay, and we are gonna to find their equivalence point. So their equivalence point will be like that. So their equivalence point is this 7 pH. Is this 7 pH? This is its equivalence. Equivalence point. This is the equivalence point. If we see the case of a strong acid and a weak base whose pH is less than 7, their pH will be less than 7. Like here their pH will be. So इनकी pH क्या 7 से कम है, 7 की pH यहाँ पर है, इनकी pH कम है, तो इनका इन्फ्लुएंस पॉइंट ये थोड़ा नीचे बनेगा. If we see a reaction between a weak acid and a strong base, इनकी pH 7 से ज़्यादा होगी, जाहिर बात है. तो ये 14 है, ये 7 है, तो इनकी pH कुछ यहाँ पर 7 से ऊपर बन रही होगी, कुछ यहाँ पर. ये इनका इक्विवेलेंस पॉइंट होगा. और जो वीक एसिड और वीक बेस है, इनका रिएक्शन की कर्व डाउनवर्ड्स जा रही होगी कुछ इस तरह से, ठीक है. और इनकी pH 7 पे ही हम इसका इक्विवेलेंस पॉइंट यहाँ पर ऐसे दिखा देंगे, ये इनका इक्विवेलेंस पॉइंट होगा, ठीक है. तो ये मैंने आपको साथ ही कर्व्स बनाना भी दिखा दी कि टाइट्रेशन की कर्व्स किस तरह बनती है. हर टाइप की अलग कर्व्स हैं जो कि उसकी pH पे डिपेंड करती हैं, ठीक है. अगर pH 7 है, इसी से हमें पता लग जाता है कि हमने एक स्ट्रॉन्ग एसिड यूज़ किया और एक स्ट्रॉन्ग बेस यूज़ किया. Similarly, if we use any kind of if the pH is less than 7, then we can find out that we use any strong acid and a weak base. If the pH is higher than the 7, it means we use a weak acid and a strong base. And if the titration curve is like downwards, then it means we use a weak acid and a weak base, and the reaction is very difficult to form. That's why we shift our titration to a non-aqueous titration to perform this reaction. So this was all the types of acid base titration. Okay, so after doing all of this thing, we use an indicator in the case of acid base titration. Okay, so we know that we use these kind of reagents within a titration reaction. So ये सारे reagent है जो हम use कर सकते हैं, लेकिन reagent के साथ titration में एक और चीज़ भी होती है. So I'm gonna to discuss some components of titration. तो ये मैंने क्या डिस्कस किए हैं, वी डिस्कस द कंपोनेंट्स ऑफ टाइट्रेशन. अब मैं यहाँ पर आपको बताती हूँ हमने क्या डिस्कस किया. वी डिस्कस द कंपोनेंट्स ऑफ टाइट्रेशन एंड द फर्स्ट कंपोनेंट इज आवर रिएजेंट्स. और रिएजेंट्स ये सारे हैं, स्ट्रॉन्ग एसिड स्ट्रॉन्ग बेस, स्ट्रॉन्ग एसिड वीक बेस, वीक एसिड वीक स्ट्रॉन्ग बेस, वीक एसिड एंड वीक बेस, ठीक है. ये सारी चीज़ें आ गई. दूसरा जो कंपोनेंट है हमारी टाइट्रेशन का, वो बहुत इंपॉर्टेंट है, एंड दैट इज़ आवर इंडिकेटर. अब इंडिकेटर क्या है, हम इसकी स्टडी कर लेते हैं. रिएजेंट मैंने आपको सारे बता दिए, उनकी कर्व्स किस तरह से आती है मैंने सारे बता दिए, उनकी पीएच का क्या चीज़ है वो भी बता दिया. अब आ जाती है इंडिकेटर. So indicators, they are the compounds that change the color according to the pH. So they are the indicating agent, and whenever the pH changes color. ठीक है. So it is indicating us some pH change. And how we gonna to know that the pH is changed? It's changed its color. And we can determine the end point of titration. So at the end of titration, this indicator change its color, so it is help us to find out whether the titration reaction end point is occur or not, or whether the reaction is continuous or yeah. Okay. Okay, so as we have discussed, there are many types of titration. So in the acid base titration, we use the indicator, and its name is phenolphthalein. Okay, this is the indicator that we use when we do acid base titration. There are many types of indicators but for every different type of titration we use an different indicator. So for acid base titration, we are gonna to use an indicator whose name is phenolphthalein, and its color have different situations or different things. Like if I'm going to tell you that this is a conical flask and I have acid here. Okay, so this is the acid, HCl is here, and I have added the phenolphthalein into it. What color it shows? It has the acid, the pH is very low, so phenolphthalein is going to show by the changing its color. So phenolphthalein become colorless at that point. Phenolphthalein is colorless. It's mean whenever the phenolphthalein become colorless, it means the acid is present here. Okay, after that, after adding the indicator, we add base because we have two reagents, acid or a base. Now we add any base into it, like I add a strong base, NaOH. Okay, I'm using this reagent. Okay, and after adding the base, phenolphthalein changes color because the pH now change. Okay, first the pH is low, now the pH will become equal to 7. So that's why now the phenolphthalein color become pink. Phenolphthalein always shows pink color when the base adds. Okay, now I'm gonna to discuss the second case. Second case is when we have a base in the conical flask. Now in this conical flask, I have a base like NaOH, not acid. Now we add phenolphthalein into it, and the phenolphthalein shows pink color. And when the phenolphthalein shows pink color, it means the pH is greater than 7 because it has the base. Now we will add acid into it. Any acid, uh, like I'm gonna to add a strong acid like HCl I add, and now its pink colors change into colorless again. It's mean it is phenolphthalein can indicate first we add acid or a base, or at the last what we add, whether it is acid or base we can check it out. If the last color is the pink, it means at the last we add a base. If the last color is colorless, it means we at the last we have added a acid into it. And we can use other indicators, not only phenolphthalein. We can use methyl orange, we can use bromethyl blue, we can use a litmus paper, any indicator we can use it. So after discussing the whole components of titration, I'm gonna to tell you the whole process of titration, so how the titration is gonna to occur. So let's discuss it. Okay guys, let's discuss the process of titration, that how you are going to perform the titration process, how you perform it in within your lab. So the first step that you have to do, you have to prepare a solution. You have to prepare what a standard solution, a standard. And what kind of this standard solution is? This is those solution whose concentration it is used as a reference. Okay, it can be a primary standard solution that used by industries, and it could be a secondary standard solution. The secondary standard solution is made by us, so it means you are going to prepare a secondary standard solution here, and then after that you will add your this standard solution to unknown solution using a burette. So your unknown concentration solution, which is a sample or analyte, can be a acidic, can be a base, and then you will add indicator into it, and then you will gonna to find whether this is the indicator will shows the changing of the color, and then you will find out what is gonna to happen. So first of all, I'm gonna to draw a diagram here. This is a tripod stand having a conical flask here, and above this conical flask we have a burette whose shape will be like this. So yeah, so this is a burette here, it attached with this stand here, and yeah, so in this is a burette and this is conical flask. So in the conical flask we have the thing whose concentration is unknown to us, and in the burette we have the thing whose concentration we know. So you put your standard solution into the burette, and unknown solution will be in the conical flask, and then you add your standard solution into the burette, and then this standard solution added to the conical flask with the indicator, and then it changes color, neutralization reaction will happen, color change, and then we will detect what is gonna to happen there. So if we have unknown acid here, we will add the base, into the butyrate, the base will add it into the acid. First the color, yeah, also you have to add the indicator phenolphthalein like indicator into it. If you add the phenolphthalein into the acid, it shows colorless, and when the base is added, it shows the pink color. So this was the whole procedure of titration that will occur. After discussing almost everything about the titration, the last thing that we will discuss about this acid base titration is their theories. Some theories are put by several scientists about this type of titration, and the first theory about the acid base titration is the Bronsted Lowry theory. You have discussed it within your metric syllabus. So in the Bronsted Lowry theory, you use a acid or a base. A Bronsted Lowry acid, and you use a Bronsted Lowry base. So what did the Bronsted Lowry acid do? It's donate hydrogen positive ions, and what your base is gonna to do, it's going to accept this hydrogen ion. Okay, so what is the definition of Bronsted Lowry acid? That it is a species that is capable of donating hydrogen ion. And Bronsted Lowry base, this is a species that is capable of accepting a proton or a hydrogen positive ion. And the water, in the case of Bronsted Lowry theory, water is amphoteric because it can either be acted as a Bronsted Lowry acid or the base. I'm gonna give you the example of it. So its example is HCl plus NH3, which is a base. The HCl will donate its hydrogen positive ion, and NH3, it has the lone pair over the nitrogen atom. It will accept this hydrogen, and the result pair will become NH4 positive, having the 4 hydrogen atoms, plus Cl negative. The charges will form at the end. So it means HCl is a Bronsted Lowry acid because it donates hydrogen, and the Bronsted Lowry base is NH3 because it accepts the hydrogen ion. So this was the first theory about the acid base titration. The next theory about the acid base titration is our Arrhenius theory. Arrhenius theory. What this theory says, according to the Arrhenius, which is a scientist here, he defined the acid and a base as acid is something that releases the hydrogen ion but in water. So it donates hydrogen in presence of water, and the base release OH negative ion in presence of water. So the dissociation of acid and base occurs within the presence of water here. So the example of any acid like HCl in presence of water only, not the base any present. In the presence of water, it will donate. Like HCO3 will form and the Cl negative will form. Here the water accept the proton. It means water is acting as a Lowry Bronsted theory. It is accepting a proton, so it means it is a Bronsted Lowry base. But in case of NaOH in presence of water here, now what will happen? Na positive and OH negative will form. Okay, so here the hydrogen is acting as a acid because it donates the hydrogen positive ion. So this is the concept of Arrhenius acid and Arrhenius base here, which forms the charges here. So these two theories about the acid base titration is done here. Now we move towards the last theory of acid base titration, and this theory is about Lewis theory. What did this theory say? By this theory, the definition of acid and base is like base is something that will donate the pair of electron, and the acid is something that will accept the pair of electron. For example, अगर हम ले लेते हैं metallic ions like Mg plus 2 Fe plus 3, potassium positive. So these are the positive charges here. So for example, Na positive plus Cl negative, they will react to form NaCl. So Na is electron deficient, it has less electrons. So it is electron deficient, while it has more electrons. It has more electrons. And then this species having more electron, this is a base, it will donates its electron to the electron deficient one. Similarly, the reaction occurs between hydrogen positive and Cl negative to form HCl. So this is electron rich. So it will donate its electron to hydrogen positive, and the Lewis theory will form. So in the Bronsted-Lowry theory, we have seen that acid is someone that donate hydrogen ion, and the base is someone uh, that accept that hydrogen ion. In Arrhenius theory, we have seen that acid release hydrogen ion in presence of water, and the base will release OH negative ion in water. While in the Lewis theory, we have seen that acid is someone that accepts the electron pair, and the base is something that donates it. So this was the whole thing about the acid base titration, which was the first type of titration. I hope that you will like this video. In the next lecture, we will discuss the second type of titration. As the requirement of our syllabus, we will discuss the oxidation reduction titration, or which also called as the reduction oxidation reaction. So this will be discussed in the next lecture. Take care. Make sure to subscribe to my channel and press the bell icon so that you can get the notification of all the videos that I will upload in the next future. Take care. Meet you soon in the next lecture. Allah Hafiz.